Hello, my name is Alejandro Payares, and I'm going to tell you about a modified mix design method for previous concrete based on the Mohr-Coulomb failure criterion. Abstract. Balancing the permeability and resistance of this type of concrete has become a challenge in its design stage due to its high porosity that reduces resistance. The objective of this article is to study the resistance mechanics of previous concrete and propose the mentioned method. 5 sample groups were prepared with different water-binder ratio and with a porosity of 20%. Triaxial tests were applied at different confining pressures. The results showed that the Mohr-Coulomb criterion can be used to describe the behavior of previous concrete in compression. In the end, it is observed that ACC had little influence on porosity or area and fractal dimension of previous concrete, and that concrete with different ACC had similar permeability. It follows that this method improved the resistance compared to that designed by the conventional method. In cities, there is a large presence of impermeable surface, and this generates problems. But the concept of previous concrete would mean thinking about the environment and reducing problems, in addition to the absorption of acoustic noise. Some authors point out that this type of concrete is based on the adequate selection of thickness, the water cement ratio that varies between 0.27 and 0.43, and the aggregate cement ratios that are 4 to 6 by mass. It was also observed that in the compressive strength, the most influential factor is the paste content, and in the traction and bending, it is the type of aggregate. The aggregate content is determined from equation 1. Equation 2 is used to determine the cement content. The method figure 1 begins by verifying if the Mohr-Coulomb criterion is applicable to previous concrete. This through a triaxial compression test. Then the modified method procedures are proposed. Third experiments are performed according to the method, and the optimal ACC value was determined. Afterwards, the thickness of the cemented space, and the pore structures are analyzed. Concrete cylinder samples are triaxially tested at various confining pressures. If there is a linear relationship between the ultimate axial compression and the pressure, the concrete agrees with the criterion studied. Figure 3 shows the triaxial test. The maximum axial load of the triaxial system is 2000 and the maximum confining pressure is 60. Figure 6 shows the failures in the samples compared to that of ordinary concrete. One presents failure due to shear and cracks, the other does not. The sample is loaded by means of a pressure decompression test. The load is removed when it reaches 90% of the maximum resistance, and the cuts are scanned with a CT equipment as seen in figure 7. The cracks are mainly formed between the paste and the aggregate weight area of the figure. To obtain previous concrete with different content on cement and aggregate, the ACC factor replaced the experience factor 0.98 as seen in the equation 3. The proportion of the mixture of the 5 groups of previous concrete that are those of table 1 were determined by establishing 5 levels of ACC. The coarse aggregate used is basalt, and the properties can be seen in table 2. Figure 8 shows that when the pressure increased, the ultimate load also for the 5 groups, and 9 shows the linear relationships between the ultimate axial compression and the confining pressure. The cohesion value can be calculated as shown in Table 3. Figure 10 shows the effect of ACC on cohesion. It is seen that with the decrease of this, the cohesion first increase and then decrease slightly. The strength of previous concrete will not increase with ACC, and there would be an optimal ACC value. Figure um, 12 gives the results of the thickness of the cementitious paste. Figure 13 shows the relationship between ACC and the thickness of that paste. So figure 14 shows the influence of this thickness on cohesion, and it's also seen that decreasing the ECC increase this thickness. When the thickness is decreased, the cohesion first increase and then decrease. Figure 15 shows the step. Figure 18 shows that with decreasing ACC, probability will decrease. The permeability of the fibers is about 5 or 6 millimeters per second, which is an excellent value. As shown in figure 19, with the decrease of ACC, the compressive strength rates increase quickly, and then the increasing trend obviously slows down when the value of ACC reach 0.94. Figure 21 shows that flexural strength also increase with decreasing ACC. As shown in figure 22, compared with the conventional method, the permeability of the modified method is only reduced by 6.6%. However, the strength of the modified method has been significantly improved, and the increased range are 44.5% and 23.3% respectively. And the conclusions, the Mohr-Coulomb failure criterion can be used to describe the behavior of Pervious concrete in compression. Insufficient cohesion is the main reason for the failure of Pervious concrete. With the decrease in ACC, the cohesion first increased and then decreased. And that's it. Thank you very much.